Hey, Lisa.
Hey, how's it going?
Good. How are you?
Pretty good.
Good. I just heard from Blake, so he should be here for sure.
Okay.
I'm not sure about Ethan, so we'll see.
Okay.
Is this getting harder for you as it is for me? Or is it?
Yeah, this one was a little trickier than the past ones have been.
Yeah. Did you watch the videos by chance?
I didn't know. Did you?
Yeah, and they seemed to help. Like I was struggling because I worked on it a little bit throughout work today, and I was struggling. I came home and watched the videos, and they seemed to help a little bit. So let's see here.
I think the email Blake gave you was wrong.
Did
I
you?
think there's supposed to be a K after the first B, because I think it's B. Kimball Johnson.
Yeah, I think so too. Okay, I will send it again.
Okay.
I don't know why like your name and then Ethan's name keeps on popping up, but for some reason his doesn't.
That's really weird.
All right, let's hope that works. So how many credits are you taking this semester? Are you pretty full with credits or not too bad?
I'm taking 12, so just,
Yeah, keeping you busy then.
yeah, but it's good.
Yeah, for sure.
Yeah, it's not. Last semester I took 12,
Mm-hmm.
and it was really hard.
Really? What's up, Blake?
Hey, how's it going, guys?
Good, how are you?
It's nice. Yeah. Good. How are you doing? Good.
No word from Ethan yet, so I'm wondering if he's going to show up.
Oh, okay.
Should we just get going or should we wait a few minutes? Maybe I'll IM him one more time.
How'd you guys feel about this chapter?
It's a little trickier than the last ones.
I feel like he gives us a super easy one the first part of the week, and the second part of the week is like a lot trickier than.
Yeah.
The thing for me is, the thing that I struggle with are the formulas, like knowing which numbers to plug into where.
That's what I was going over a lot this time. I was like, wait a second.
Yeah, I mean, what does the N mean? What does the T? You know, all that kind of stuff is. I'm too lazy to write anything down.
Oh.
You know, like write it on actual paper, and so like I try to do it just like flipping from screen to screen, and it just doesn't work. And so I need to really write it down on some paper.
I feel it.
Yeah, I guess that's important for math, right?
I guess
Yeah.
your work.
Okay, so I was according to our individual assignment, it might be good if somebody can have the applet opened.
Okay. Yeah, I can pull that up.
Something you can do, and then maybe we can just tell each other, or a calculator available.
Yeah, I can grab a calculator.
I have a calculator ready right here.
Okay.
Oh, okay.
So if you've got the applet, and then Blake, you've got the calculator, maybe we can just help each other know, what to plug in, and I think that might make it go a little bit easier and a little bit quicker.
Okay.
That works.
Yeah.
Do we want to go over the assignment, or are we good to just jump into the homework?
I'm good with just going with the homework, but if you guys want to go over something from the assignment, that's fine.
I think
Sorry, go ahead.
I'm good either way.
Okay.
So I'm good just jumping in if you guys would like.
Yeah, that's okay. I'd say we do that too.
Okay.
If I have questions, I'll ask them.
Yeah, I'm the same too.
Yeah, we can get it figured out if we need to. Okay.
Cool.
Got to make like the right assignment.
Yeah.
That was funny.
Did you do all right on your only try for the homework you had last time?
Like a 30%.
Oh, I'm sorry.
But he did say, I emailed him and said, hey, this is a situation. He said you can take it again, and if you do bad and you want to retry, then I'll open it up. So because I guess we get 2 retries regardless.
Oh.
Yeah, that's good.
Yeah. All right. So let me make sure we're doing this. We're on lesson 7 group meeting, right?
Yeah. Okay. So do you want me to start?
Sure.
Okay. So number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Example, if the answer, is 0.8976, then you would answer 0.898 in the answer box. Okay, so on the applet, put 1.358 for the z-score. And then you would shade both to the right of the red line and to the left of the left red line. And
So
The box
it's in the middle, right? It's empty in the middle.
yeah, it's empty in the middle. So it's just blue on the edges.
Right. Okay.
And the area is 0.1745, so rounded 0.175.
So 0.175 or 0.175.
Yeah, either is fine. But it doesn't matter.
Okay.
Cool. Thank you.
That
Okay.
works. Number 4, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean than was observed in the sample. Round your answer to 3 decimal places. Example, blah. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
Okay. So we need to find the z-score.
So we do the equations in the reading, right?
Yeah. So the value is 177.6.
Minus 185, right?
Yeah.
Which is the mean, yeah. Yeah, I got my calculator.
Okay, and then divide that by the standard deviation, which is 26.7.
And then, isn't it divided also by the square root of something?
N, yeah.
Well, this doesn't give an n.
So is that what we're trying to figure out here, is the n? No, wait, no, maybe not.
No.
Would 48 not be the N then?
Oh, it is. Sorry, yeah, you're right. Sorry, you guys are right. I
No,
didn't even see that.
It's Todd. That's all Todd.
no, that's teamwork. Teamwork.
All right, give me a second. I'll input it real quick.
So it's the square root of 48, right? That's the last number? Okay.
Yeah.
Yeah. So 177.6 minus 185 divided by 26.7 divided by the square root of 48, right?
Yes.
And this is maybe me just being far removed from school for a little while, but did you know on the calculators on your phone, if you turn it sideways, it's a
Yeah. It gets fancy.
yeah, it's a fancy one where you can do parentheses and everything.
Yeah. That was an exciting day when I figured that out.
No, yeah, and just recently I figured that out. It makes all the difference.
Yeah, I got it, but I'm just going to double check my work real quick, just in case.
Okay.
Okay.
Just to make sure I don't want to get anything wrong on my part. Okay, cool. So, rounded to 3, it would be negative 1.920.
1.92. Well, you don't have to round this one to 3 because we have to put this number into the applet.
Okay, well, it's already at, the next number is 1, so.
Oh, okay. So, negative 1.920.
Yeah.
And that's our z-score, right? The negative 1.920?
Yeah.
Okay. And it's going to give us now our area, right?
Yeah. And this question, it's asking for both sides, right? So it's as extreme or more extreme. So, yeah, so we do the left and the right side, so just the middle is empty.
Okay.
So the area is 0.055.
0.055.
Mm-hmm.
Work.
Okay.
I can take, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observation, x. The distribution of the sample means some x bar or something. And then this cannot be determined from the information given.
Isn't it?
Which of the following will have a smaller standard deviation if 9 observations are
I
random?
want to say sample, but I don't know if that's correct.
I think you are correct because like the individual observations aren't affected by the observations. Actually, I don't know. I don't know this one at all.
Which
Yeah.
of,
Sorry.
Kill me off, yeah.
let's look at our
Reading
documentation.
real quick.
All right, I'm looking to see if there was anything similar on our homework.
Oh, that's a good idea.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
I think it is sample, but keep going. I don't know.
I think it is too because, okay, this is why I think it. Actually, no. Hold on.
If you want, I'm just reading it. And it's in the first part of the reading. It says probabilities involving a mean, all that stuff. It
Yeah.
gives an example of based on a sample mean, and it just I don't know. From what it looks like, the sample mean when calculated has a smaller standard deviation than the population mean.
That works. Help me understand what they're asking. So which of the following will have a smaller standard deviation if 9? So there's 9 observations, right? 1, 2, 3, 4, 5. If 9 observations are I guess I'm trying to wrap my head around what they're even asking us.
Yeah, I'm a little confused on that too.
I think
Okay.
it's. I don't know. This is. I don't know if I'm just tired or what.
Okay,
Right.
so hold on. Let's go back. Does anybody remember what the definition of standard deviation is for just a sample, not a sample, just of individual observations? Do you remember what the?
That was like 2 chapters before. Let me see real quick. Oh my gosh. I think the last part of the question, the 9 observations, is just there to throw us off. I don't think that actually has to do with the question itself.
Yeah.
Maybe I'm wrong. I don't know.
No, and you're probably right. I can't tell you anything any way whatsoever. So I think your guess is a lot better than mine. That's for sure. Which of the following will have a smaller standard deviation?
What the heck?
The distribution of individual sample.
Okay, hold on.
Where are you looking, Elisa? Maybe.
I'm looking in lesson 3 because I just want to find the formula for the standard deviation for just like regular things.
I'm in 4, and I think that's where it's.
Oh, okay.
In 4, you said? That's where we're looking?
Yeah. Oh, what the heck?
I'm going to check the assignment and see if there's anything on there.
Okay. I think that it will be smaller in the distribution of sample means because the distribution of sample means, its standard deviation is just the standard deviation of the individual observations divided by the square root of the sample size.
I was about to say that. It says here in the reading that it's you add them all up and you put them together.
You add the 9 that they. Is that what you're saying?
Yeah, I think so. I don't know. This is a little confusing, but I agree with Elisa. I think it is a sample.
The sample, so 5, the middle one, the distribution of sample means. That
Yeah,
one? Okay.
I think that's what it is. Because you're dividing by the square root of the sample size, so it has to be smaller. Because the sample size is always going to be a whole number, or like a positive number.
Right. Yeah. So it's always small. Yeah.
Okay, that works.
Okay.
Cool. That was tough. All right. I'll read this next one. Which of the following results implies that the spread in standard deviation decreases as the sample size increases? The normal distribution, the 68, 95, 99.7% rule, the central limit theorem, and the law of large numbers.
I think
Law
it's
of large numbers, right?
one of the last two, and I know we talked about this last time, but maybe help me remember the difference between the central limit theorem and the law of large numbers again.
Okay, so the central limit theorem, that's the rule that says that if your sample size is large, the distributions of the mean will be normal.
Right.
And then-
Smaller, right, because more
Yeah.
accurate. Okay.
And then the law of large numbers says that if the sample size is large, then the x bar will be closer. Each x bar will be closer to the actual mean. So like the law of large numbers is like if the sample size is large, then the spread will be smaller.
Yeah.
So that's the answer, right? The law of large numbers, is that what you said?
Yeah.
That makes sense. Okay.
Woo. Okay.
Making progress.
I'll read the next one. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean mu of 150.8 and a standard deviation sigma of 8.8. One, use this information to answer questions 7 through 10. Okay. 7. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places.
Is that the sample mean, or is that n?
This is just a z-score for a value, not for a sample. So it's just the x minus mu divided by sigma. Right?
And earn a score of 160 on the quantitative portion of the source.
Because we're just doing it about one score. We're not doing it about a mean of scores.
Yes.
Okay.
Means, what is the z-score? Yeah, to Diane's score. Yeah.
Okay. So it's just 160 minus 150.8 divided by 8.8.
Divided by 8.8, is that what you said?
Yes.
And we're not doing the square root, we're not doing the divided by the square root because it's just that individual person's, right?
Yeah.
Okay.
Okay, so I'm rounding, correct? Oh, I don't need to, actually, so it's fine.
Okay.
So 1.045. Does that sound correct?
It sounds a little big.
Let me go over it one more time. So it's 160 subtracted by 150.8,
Yes.
and then divided by 8.8.
Yeah.
Or is it 158 subtracted by 160?
No. It's 160 minus 150.8.
Hmm.
Oh, wait. Sorry. That does sound right. I'm sorry. I'm off of it today.
I think
all the stars, don't worry.
Yeah, I agree. Sorry. And I keep moving my screen if I'm making you sick. Sorry.
Okay.
No, but are we shooting? That sounds okay?
Yeah.
Yeah.
045 then?
Yeah. Sorry. For some reason, I thought 160 was only 0.2 bigger than 150.8. Like, I was like, how could that be so big if it's 0.2 divided by 8.8? Okay, sorry. I was really off. Okay.
Alright.
Okay.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Round your answer to 3 decimal places.
So this, we will do the square root because it's a random, right? And it includes everybody?
No, this one, we just take the z-score that we found and put it into the applet.
Oh, okay.
Yeah, I was gonna say because we don't have the fourth number, it wouldn't make any sense.
Right. Okay.
So, is it asking for if they score higher than her?
Yeah, it's higher than 160. Yeah.
Above 160. Yep.
Okay. So to do that, I put 1.045 into the applet and then just do the right side.
Right.
Okay. So it's 0.148.
Fantastic.
Perfect. Number 9. A random sample. Is it my turn?
Yeah.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Round your answer to 3 decimal places. Okay. So we add those all up, right?
Yeah.
And then divide it by 1, 2, 3, 4, 5.
Yeah.
That'll give us our mean.
Which is 160.
160.
Yeah. That's the mean, right? And then we're going to solve with the equation from the reading.
Yes.
Cool.
Right. So, and then 5 would be n, correct?
Yeah.
Okay, let me see this.
We're still using the GRE numbers, right?
Yeah.
Okay.
Yeah, I don't want to mess this up. Okay, so the value is that 160?
Yes.
So I'd subtract that by 150.8.
8.
Mm-hmm.
Okay. Sorry. Once you get this, so I'll let you finish.
No, go ahead. Go ahead.
I was just gonna say. So when do we know? Remind me how we know when we use when we do divide by the square root and when we don't.
We do divide by the square root when you when the value is a mean of something. So like, yeah. So like this example, we're taking the mean of like those 5 students.
Right.
So we do divide by n. When in the other one, it was just the one person's score.
Right. Okay.
So
So this one we are going to, right? Because it's a more than one.
yeah.
Okay.
You could, like, in the reading it explained it, like, it's the same if you do it with 1 because you'd just be dividing by a square root of 1, and so it'd just be dividing by 1, which is the number.
Right.
So, like,
Okay. That makes sense.
like if you just think
If I
about
had
it,
square root in my mind the whole time, I would either way I'd come up with the right answer.
yeah, because it would just be a sample size of 1, and it would be fine. So,
Right.
Okay, sorry guys, just to verify. I have 160 minus 150.8 divided by, in parentheses, 8.8 divided by the square root of 5. Sound correct?
Yes.
yeah.
Okay, the answer I got was that's a round?
Yeah. Round to 3 decimal places.
Okay, this is a really large number,
Oh, that, like, how large?
like in the hundreds.
So what does a z-score correspond? No, that doesn't sound right, right?
That doesn't seem right.
No, it doesn't.
All right, so you did 160 minus 150.8, right?
Yes.
So that's 9.2, right?
Yeah.
So 9.2 and then divided by, what was the other number?
8.8 divided by the square root of 5.
You know what happened, guys?
What?
I didn't put parentheses in the top part of the equation.
Oh. Okay.
That was a rookie mistake right there.
Ugh,
I'm glad I clarified.
so annoying.
Okay, there we go. This is way better. This is 2.338.
2.338?
Yeah.
Okay, that seems right.
That's good.
That's 1,000 times better. Oh my gosh.
Okay.
But bury each other, right? To bear each other up.
Yeah.
So I don't know what to do without you guys. That was a rookie mistake. Holy crap.
Hey, I just learned how to figure that out on my phone, so I think you're good.
Okay, number 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. Fancy. Okay. I'll do the applet then. So 2.338.
Is that 5 significant at all? Or is that,
What?
Is that 5 significant?
That's a good question. What is the probability that 5 randomly selected students will have a mean score that is greater?
Because you should input what we just found in the last question.
Yeah. It's not significant because the parent population is already normally distributed. So we don't, it's just not significant at all.
Right.
Okay. What would we do without you, Lisa?
Right.
Okay, the answer is 0.0097.
All right.
My turn?
Yeah, go ahead.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is less skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who were selected? Less skewed, right skewed, approximately normal. We cannot determine this form.
Approximately normal. Yeah.
Yeah, because it's more than 30, right?
Yeah.
Okay.
If the GPA average is really 3.5 at BYU Idaho, then that is incredible.
There's
Yeah.
no way it's true, unless it's all art majors and communication majors.
Right.
Yeah.
And no athletes.
Yeah.
Yeah. That's ridiculous. Okay, I'll read the next one. What is the mean of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that can be drawn from the parent population. So that looks like, am I doing the 81 subtracted by, no.
No, this is just it's 3.5 because it's just the definition, like the mean of the sample means is equal to the population mean.
Oh, yeah.
Wait, what? So what is it? Maybe I was distracted. My son is distracted.
Oh, it's okay.
The distributed sample means for all possible samples. Sorry, go ahead.
It's just 3.5 because it's just the definition of the mean of the sample means is equal to the population mean.
Oh, okay. That works. So 3.5.
Yeah.
I knew that, but it's cool.
There's just so many, stats. I feel like all these questions, they're all super similar to each other. It's just, you just have to find, the different wording in it, and then it's, changes the answer completely. Because you're doing something totally different. But
I'm wondering what our final is going to be like. Are we going to have all these, all these different formulas and...
Well, at least for our first test is next week, and we get to fill a whole 8.5 by 11 page with notes for it. Yeah. So I don't.
All the chapters, jeez.
Yeah. I'm sure we'll get to have notes on the final.
Yeah, I hope so.
Okay.
What? We don't get a team thing?
Yeah. We should have a team final. We should just suggest that to him.
Probably a group test we have to take or something, and then the actual final.
Probably, yeah. Okay, I'll do the next one. So, what is the standard deviation of the sampling distribution of the random variable x bar? The mean of the 81 students who are selected.
Is that 0.7?
Huh?
Is that 0.7?
No, I think we take 0.7. We do the formula that was in the reading, x bar minus mu divided by sigma divided by square root of n.
So 81 students minus...
Oh, wait, no. Sorry. No. It's just 0.7 divided by square root of 81.
Oh, yeah, because you're... Okay, yes. Okay. That is...
Yeah. The standard deviation of a sample distribution is the standard deviation divided by the square root of n. Right? Does everyone agree with that?
Yes. We just read this, I think.
Okay. So
to 3 decimal places, it would be 0.78.
Okay.
All right, so what you did is on this one you took, let's see here, what numbers did you divide by the square root of?
I did 0.7 divided by the square root of 81.
Okay.
That's
Okay.
pretty much the same as before, just a bit of a difference.
Right,
Yeah.
okay. Looks good.
I don't know if that's supposed to be like that.
Wait, so we needed 3 decimals, 0.78?
Yeah.
There we go, okay.
It's 0.7s all across, but so. Good.
Okay.
Yeah. So, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Is that in the applet? Is that when we do that?
We have to figure out the z-score, right?
Yeah.
And then we'll plug it into the applet.
Yeah. So wait, hold on. For 13, did you say it was like 0.777 repeating?
Yes.
So we should do 0.778.
I think so, yeah, right? Okay, because it's 3 decimal points,
Yeah.
or 3 decimal places.
Yeah.
Does that make sense, Blake?
Well, it's 0.07777777.
Oh. Okay. Sorry, I thought you said
Did I miscommunicate on that one? Sorry, guys.
I thought you said 0.7, not 0.07.
My bad. Sorry.
So it's 0.077, right?
Yes.
Okay.
Well, it's 8. 0.078.
0.078.
Okay.
Okay, that works.
Yeah, I
Sorry.
don't know if I confused anyone. I probably did.
Oh,
Okay. So for 14, we got to find
Z-score?
the z-score. So we do 3.3 minus 3.5 divided by
Okay, that makes more sense. Okay.
0.7 divided by the square root of 81.
which is 9, right? So 0.7 divided by 9.
Yeah.
Okay, once again, I want to verify. This time I have parentheses, don't worry. Okay, so 3.3 is subtracted by 3.5 divided by 0.7 divided by the square root of 81. And I got negative 2.571.
Then you're going to plug that into the applet, right? Do we need, or is that our answer? What is probably the mean GPA for rate? So less than 3.3.
So I do need to plug that into the applet
Okay.
because the applet is what tells us the probability. We want to see what's on if the probability that they will score less than that.
Yeah, so
Less
left side.
3.3, yeah.
Okay. And does it say round to 4 decimal places or 3?
3.
3.
Okay. It is 0.005.
So and this one's just greater than 3.3, and so it's so the next one, 15, instead of being less than 3.3, says that it's greater than 3.3. So is that simple, or is that something we have to figure out again?
Would that just be highlighting the right side instead of the left side?
Yeah, or it's just 1 minus 0.005. But, like, I can just do that. Like, oh, darn. Sorry. I accidentally moved it, so I have to type it in again. So it'll be 0.995.
Wow. That makes sense because it makes 1 total.
Right, okay.
Yeah.
All right, do we want to go through them really quick?
Yeah.
Yeah, please, actually. Cool, so first one true, second one true. Anybody?
Yeah.
Number 3, we put 0.175, correct?
Yeah.
Number 4, 0.055.
Okay.
5, the distribution of the sample means, not individual observations.
Okay.
6, we put law of large numbers.
Okay.
7, 1.045 for the z-score.
Yes.
8 is 0.148.
Okay.
9 is the z-score of 2.338.
Yep.
10 is 0.0097. 11 is approximately normal. 12 is 3.5, 13 is 0.078, 14 is 0.005, and 15 is 0.995.
All right, looks good.
Okay.
Okay.
100%. Good job.
Woohoo!
Good job, Anthony.
Moving my score up. Thanks, guys.
Awesome, guys.
Awesome. Good job.
Perfect.
So, will you post the link to this, Todd?
Yeah. Blake, did you go in and type your name under our last assignment and say that you were there?
I did this morning. I did it just in time because he graded it this afternoon.
Did you? Okay, good.
Okay.
All right,
Awesome.
I'll go and do it.
All right. See
Like-
you guys. Oh, wait.
Bye.
Am I doing it next week?
Yeah, is that okay?
Yeah.
I'll do it.
Okay, awesome.
All right.
See you guys Monday.
Sweet. Bye.